So this is the implementation of the SEPIC converter that we are working on for our final year project. So this is the assembled board. We have not placed the microcontroller on the board yet. We are using it externally to provide the PWM. So the PWM is coming to the gate driver over here, as we can see. So right now we are feeding. So right now we are giving it an input voltage of 12 volts from the mains. So this is a 12 volt supply. So as you can see, this multimeter shows the output voltage, whereas this is the input current. So as we can see, we are boosting the voltage from 12 volts to 24.7 right now, which is a stable 24.7. So by using this potentiometer, I'll vary the PWM. So we'll go into the buck region where the voltage will be decreased, and we'll go into boost region, and we'll see how exactly it is performing. So right now I'm going into the buck region. So I'll be decreasing the output voltage. This is the output lamp that I'm showing as a output to show the output power. So as we can see, the bulb is glowing right now. So I'll decrease the output voltage, as you can see in the multimeter. So this is the input current and output voltage. So as we can see, steadily we are decreasing the output voltage. So it's coming down. It's a steady state output voltage. We can go down till. So as you can see, we have arrived at almost 12.3 volts. We can go down further. So 10 volts, 8.5. If I just leave the potentiometer, it's at 7. It's at a stable 7.8 voltage. We will go further down. So 4.8, 3.6. As we can see, we are bucking the voltage from 12 volts to almost like 3 volts, and go further down. So as we can see, at certain point it just goes to 0. So right now we are at 1.4 volts. I think we can go further down. So 1.1. Yeah, so at around 1.1 the PWM gets a little unstable, so it falls just to 0. So we can go till 1 volt. Now we'll go into the boost region, where the voltage will be increased from 12 volts. So we are going into the boost region. So I'll be increasing the voltage. So as we can see, the voltage is increasing. 5.7 volts, 8, 11. So we crossed the 12 volts region. So we are boosting the voltage right now. So 19 volts. The bulb is glowing dim, as you can see. 20, 21. Our output voltage range is 0 to 60. So we'll try to achieve 60 volts. So 26, 27.8. So I'll just increase the voltage. 36. So yes. So we have reached around 53 volts. We'll try to go to 60. So the voltage can be increased further too, but right now we'll just stop at 60 volts. So around 60 volts, the input current is around 180 milliamps. As we can see over here, the bulb is glowing very bright. Also, this is a coupled inductor that we have made customly with windings. And so this is the overall implementation of SEPIC converter, and we've shown successfully that the voltage can be stepped down and stepped up as well for a constant input of 12 volts. So this is the output duty cycle of the PWM. So right now the range varies from 0 to 78. 0 being the maximum PWM and 7 being the 78 being the minimum PWM. So right now we are at 7. So varying the potentiometer, as we can see, by varying the potentiometer, the PWM also changes. So this is the main power section of the SEPIC converter. We'll be further showing with respect with the OLED as well. Thank you. Hello. So this is the implementation of the SEPIC converter that we are working on for a final year project. So right now what we have done is placed, this is the prototype PCB that we have made. It has the STM32 microcontroller as the main as a main board over here, and has an OLED too. So the purpose of the OLED is to display the voltage, current, and the output power. So right now we are feeding it an input voltage of 12 volts from the main. So this is the 12 volt input. It's going to the main PCB, and what we are doing is boosting the voltage. So this is the output voltage. This is the input current. So we are boosting it to around 34 volts. Right now it's 33.8. So as you can see, the value is being displayed. It's not exactly close to the output value, but it's somewhere close. 33.8. Yeah. So as you can see, it's 33.88, which is very similar to the output voltage that we're getting on the multimeter. So the current section, so the current that we have that is being shown is 1. So that value is not proper. It's a random value, as we have not implemented the current sense right now. So the current this IC holder, this is basically for the current sense part. We are not implementing it right now, but it will be done in the later stage. The output, so basically we have connected a bulb. There's a 15 watt bulb at the output, around 330 ohms. So as you can see, it's glowing, and the output voltage it's constant around 33.7, 33. It's varying a little. So that value is also displayed, as you can see on the OLED screen. So this was an implementation of the OLED and along with the STM32 for the main SEPIC converter. Thank you.
Inilah usianya lijan deh. Oh ya.
Coba langsung yuk. Berkekarya Pak Menegasi. Oh, mana? Idea mana sir? Height ke bade? Ale? Height ke bade?
Baru tu ऊपर dah pada.
Upar